Okay, today we're going to start on 5.3. We're going to notes on properties of trig functions. Last class we kind of touched on the basic sine, cosine, tangent, cosecant, secant, and cotangent, and what they are. I just want to show you where these identities are coming from. So if you're just kind of looking at a coordinate plane and you have some coordinate x, y, and we were to drop that right triangle down, the x represents the horizontal distance, y represents the vertical distance, and theta is always our reference angle. This becomes our radius because we are looking at a circle that's going around that triangle. If we think back to our SOHCAHTOA days, sine was opposite over the adjacent. So we look at the opposites. Sine is opposite over the hypotenuse. So it's opposite over the hypotenuse, and in this case our hypotenuse is r. So that's where y over r is coming from. If we think about cosine, which is the adjacent side over the hypotenuse, so again we're looking at x over r, and that's where this identity is coming from. And if we talk about tangent, we're looking at the opposite over the adjacent, and that's why that is y over x. Our cosecant, secant, and cotangent are just our reciprocals of sine, cosine, and tangent. Most of the notes today will be a review of what we kind of did last class. So let's take a look at finding the 6 trig functions if our theta is 330 degrees. For each time, what I'd like you to do is draw a triangle for each one. That's going to help get those coordinate points of the unit circle into your head. We're rotating counterclockwise because this is positive. We have a 330 degree turn, and that's going to leave us with a 30 degree reference angle. If we dropped our triangle up this way, we learned with our special right triangles that across from the 30 is 1/2, across from the 60 is √3 over 2, and since we're in our unit circle, our radius is 1. Since we're in quadrant number 4, the y value here is going to be negative. So if I was looking at my xy pair here, it'd be √3 over 2, negative 1/2. Now remember, sine is y over r. Since the radius is 1, we're just looking at the y coordinate here, so that would be negative 1/2. Cosine is x over r. So again, we're just looking at x because that radius is 1, so it's going to be √3 over 2. And tangent is y over x. So that's going to get us 1/2 over, negative 1/2, over √3 over 2. These 2's cancel. We get negative 1 over √3, and then rationalize, we're looking at negative √3 over 3. Once you have your sine, cosine, and tangent, all you need to do is take the reciprocals, the flips of each of these. So cosecant would be negative 2. Cosine would be 2 over √3, but again, that needs to be rationalized, so we get 2 over √3 over 3. And if you rationalized over here, take a step back and flip this piece here, because then the radical will wind up in the numerator. You won't have to do any more rationalizing to get it back there. Okay, so let's take a look what happens now when my theta is negative 4 pi over 3. If we're in radians, we want to start thinking about radians. Because the denominator is 3, it means each half circle's been cut into 3 congruent pieces. And the negative is making us rotate counterclockwise. So from here to here would be 3, but I need 4/3, so I'd be 1 more over here. We're going to drop that triangle down. Our reference angle theta is going to be sitting there. If you think about 3 pi over 3, that's really a 60 degree angle. So this piece is going to be √3 over 2. Our 30 would be here. We have 1/2. And again, our radius is 1. Because the x coordinates in quadrant 2 are to the left of the 0, that means that coordinate's going to be 0. And the coordinate we're looking at here is negative 1/2 √3 over 2. Alright, so again, we said sine is y over r. And in this case, it's just going to be our y value here because the radius is 1. So √3 over 2. Cosine is x over r. So looking at our x value, so that's negative 1/2. And tangent is y over x. So that's going to be √3 over 2 over negative 1/2. These guys cancel here. We're going to be left with negative √3. Once you got your sine, cosine, and tangent, we just do the flips here. So we're going to have 2 over root 3 rationalized will get us 2 root 3 over 3. The reciprocal of this guy will be negative 2. And if we're looking here, we're going to get negative 1 over root 3, which again needs to be rationalized to root 3 over 3. All right, so let's continue on. We did a little bit of these last time. These here are going to take us off the unit circle. They're giving us a point, and we still need to find our 6 trig functions here. If I'm looking at the point negative 7, 24, that's going to be in quadrant number 2. So there's my triangle. These do not need to be drawn to scale. My outside point here is negative 7, 24. X represents the horizontal length. Y represents the vertical. This is a Pythagorean triple. If you didn't get the triple, you certainly could have used Pythagorean's theorem to find 25 here, because we do have that right triangle. Sine is y over r, so it's going to be 24 over 25. Cosine is x over r. And remember, we're in the unit circle, so we have to take into the fact that we don't have a 1 sitting here. So that's negative 7 over 25. Tangent is y over x, so that's going to be negative 24 over 7. If you forget these here, remember you can always revert back to SOHCAHTOA. Sine would have been the opposite over the hypotenuse, so you have a failsafe if you draw your triangles each time. Once we have this, we take the reciprocal, so we have 25 over 24, negative 24 over 7, and negative 7 over, this should have been 25, sorry guys, 25 there, and negative 7 over 24. Same thing here. Think about which quadrant you are in. If they're both negative, we're going to be in quadrant number 3. So there's our right triangle. The point here is negative 2, negative 4. The x represents the horizontal distance. The y represents the vertical. Using Pythagorean's theorem, we wind up with 20. So we're going to wind up with 2 root 5 for the hypotenuse. If I'm looking at the sine value, y over r, that's going to be negative 4 over 2 root 5. That will rationalize down to negative 2 root 5 over 5. Cosine's going to be the opposite over the hypotenuse, or x over r, which is negative 2 over 2 root 5. And that will rationalize down to negative root 5 over 5. And then tangent is y over x, so it's going to be negative 4 over negative 2, which would get us a positive 2. The reciprocals of these guys, again, if you rationalize, take a step back, it'll be a little bit easier. So this will be negative root 5 over 2, negative root 5, and then the flip of this guy would be 1/2. All right, so let's flip our papers over. We need to be able to recognize which quadrant we're in. This is just a little, like a mnemonic memory device to help you remember. All students take calculus. Here it's just saying all of the trig families are positive in quadrant 1. The sine family, which is sine and cosecant, are positive in quadrant number 2. T stands for the tangent family, which is positive in quadrant 3, and C stands for the cosine family. I'm personally not a big fan of these. I just like you to kind of think about what quadrant you're in. So I'm not going to be working with the all students need calculus. If it's a tool you want to use, certainly go ahead and do so. What I like to do is just make myself a grid and just say to myself, okay, I need to find out what quadrant theta is laying in here. And it's telling me sine is less than 0. Where would sine be negative? Remember, sine is representing the y values, and anything below the x-axis is negative. So that would either be in quadrant number 3 or 4. So I put a check in quadrant 3, and I put a check in quadrant number 4. And then I think to myself, where is tangent positive? Where is it greater than 0? since it's y over x, both signs would have to be the same. They would both have to be positive, or they would both have to be negative. That would happen in either quadrant 1 or quadrant number 3. Where you get the double check is where your angle theta is lying in. So our answer here would be quadrant 3. Looking at number 2, if I think about secant's part of the cosine family, and cosine's represented by x. Where is x less than 0? That would be to the left of the y-axis, so that would either be quadrant 1 or quadrant number 3. And then we have the cotangent of theta, which is part of the tangent family. We want to know where is that less than 0. Because of this y over x, the signs would have to be different, and that happens in quadrant 2 and quadrant 4. The double checks wind up in quadrant number 2. So now we know theta is sitting in quadrant number 2. Okay. They talk about periodic functions here. And all that means is where does the function start to repeat on the unit circle. For now, I just need you to know that sine and cosine families have a 360-degree period. So that will help us to find some coterminal angles if we get some bigger numbers. For the tangent and cotangent family, it's either 180 degrees or pi. So basically, if you just find a coterminal angle, it'd be a little bit easier to help with these guys. And you really don't even need to do that at all. You could just say, how about what's the cosine of 495 degrees? I make one full circle at 360. I need to go another 135, getting me a 45-degree reference angle there. Or you could have just subtracted out the 360 in here and then said, what is the cosine of 135? Either way works. It doesn't really matter to me. If I think about cosine of a 45-degree angle, the coordinate is negative root 2 over 2, root 2 over 2. Cosine is the x part of that, so the answer here would be negative root 2 over 2. If I think about tangent family, I could add 360 to that and help get a coterminal, and that would have been the tangent of negative 210. Or you can just go ahead and make the full rotation. Because it's negative, we are going counterclockwise. So that's going to bring us, if you go all the way around, you would need another 210. Or you could use that coterminal. That doesn't look very good. You could use that coterminal of just negative 210 sitting right there. That's going to give us a 30-degree reference angle here. So that means that the y value is 1/2. The x is negative root 3 over 2. They're asking for tangent. Tangent is y over x. So we have 1/2 over negative root 3 over 2. The 2's cancel, getting us negative 1 over root 3. And then rationalizing, you get negative root 3 over 3. I'm just going to switch colors here because we're kind of bumping into the next problem. We have the sine of 9 pi over 4. If you don't want to find the coterminal angle, just kind of figure out where we're landing. Each semicircle is getting cut into 4 congruent pieces. So we're going to count 4, 8. I need 9, so I need to go one more. We wind up over here. This is a pi over 4 reference angle, which is our 45-degree. So our coordinates out here are root 2 over 2. It's asking for the sine of that. Sine is our y value. So our answer here would be root 2 over 2. For cotangent, over here we have 11 pi over 3. Now each semicircle is being cut into 3 congruent pieces. Let's just start counting. 3, 6, 9. If I went one more, that'd be 12. That's just a little too much. So we're going to wind up over here, winding up with a pi over 3 reference angle, which is the same as 60. That's going to get us a coordinate of 1/2 negative root 3 over 2. We're looking for cotangent, which is x over y. So again, we're at 1/2 over negative root 3 over 2. These guys cancel, negative 1 over root 3, and then, of course, rationalized. let's continue on. They want us to find all these trig functions here. And first we need to figure out what quadrant theta is laying in. So let's just go back to what we did at the top of the page. I'm looking at sine theta. I see it's positive. Sine's represented by y. Where are the y's positive? That's in quadrant 1 and quadrant number 2. It's telling me cosine of theta is negative. Cosine, which is x, is negative in quadrants 2 and 3. My double checks wind up in quadrant 2. So that is where angle theta is going to be sitting. Now remember, sine is the opposite side over the hypotenuse. So the opposite side is 1, the hypotenuse is 3. Cosine is the adjacent side over the hypotenuse, so the adjacent side is now going to be negative root 2 over 3. Now I have all three sides, so we can go ahead and name the rest. Cosecant is the reciprocal of sine, so that's going to be 3. Secant is the reciprocal of cosine. So that's going to get us, it's going to take a little bit of work here. It's going to be 3 over negative 2 root 2, rationalizing. We're going to get 3 root 2, root 2 times root 2, so it's going to get you 2 over 4. So this guy is going to be negative 3 root 2 over 4. Tangent is y over x, so that's going to be 1 over negative 2 root 2. And that guy will rationalize to negative root 2 over 4. Cotangent would be the reciprocal. And again, when I said when you take in the reciprocal, if you rationalize, take a step back. So when you flip it upside down, that radical winds up on top. So negative 2 root 2. All right, let's look at the next problem. First thing we want to find out is what quadrant are we lying in. It's telling me sine is negative. Sine is represented by y. Y values are negative in quadrants 3 and 4. Secant is part of the cosine family. As looking here, it's positive. Where is cosine positive? That's x. That's represented in quadrant 1 and 4. So I know this guy, theta, is sitting there in quadrant number 4. So there's theta. Sine is the opposite side over the hypotenuse. Secant is the hypotenuse over the adjacent side, so 21's winding up there. Cosecant would be the reciprocal of this, negative 5 over 2. Cosine would be the reciprocal of the secant, so that'd be 21 over 5. Tangent is the opposite over the adjacent side, so it's negative 2 over root 21. Rationalized, looks like negative 2 root 21 over 21. And the cotangent of this would be the reciprocal. So we are looking at negative root 21 over 2. All right, and we've got one more problem to settle out. So I'm looking at number 9 over here. I can see that I've got a sine value that's positive. Whoops. I got a sine value that is positive. So sine is positive. Remember y, quadrants 1 and 2. I don't have a value for cotangent, but it's telling me it's definitely negative. So where is the tangent family negative? That's in quadrant 2 and quadrant 4. So this theta is lying in quadrant number 2. Let's just switch colors here. So I'm looking at quadrant number 2. There's our angle theta. I do know that sine is opposite over the adjacent side. They didn't give me a value for cotangent, but I can use Pythagorean's theorem to help figure this out. So you're going to say 2 squared plus x squared is equal to 3 squared. And you're eventually going to get to an x value of root 5. Now remember, we're in quadrant 2. The x values are negative. So you always need to be conscious of what quadrant you're in to figure out what's positive, what's negative. Cosecant would be the reciprocal of the sine, so we're looking at 3 over 2. Cosine would be the adjacent side over the hypotenuse, so it's going to be negative root 5 over 3. Secant would be the reciprocal of this, so it's going to be negative 3 over root 5. Rationalized. You get that. Tangent is the opposite over the adjacent, so it's negative 2 over root 5. Rationalized would be negative 2 root 5 over 5. And then cotangent would be the last one here of negative root 5 over 2. Okay, and with that we conclude 3.2. We will continue on with this with the next lesson.